in a sophisticated.
Hey kids, it's Matt here. So, FRQ Unit 6 AP Classroom Review. A little bit of thermo, a little bit of bonding, a little bit of tying things together in energy. Pretty straightforward assignment. Let's walk through the solutions, make sure we're all on the same base. Thought these were pretty decent questions and nothing very hard for anybody to worry much about, but worth touching on to get a good review going into the exam. So here's what we've got. They've given us what looks like a heat of solution curve, and in this case, the temperature looks to be dropping. The first question is really just read the graph for me. Well, if I'm reading this, it looks like my line here is at 22.6. We're starting up here at 24.8. So what's delta T? 24.8 minus 22.6. Sorry, 22.2. I've got the answer on my mind. I've got a 2.6 temperature change. Sorry, 2.6 is your temperature change. I don't think anybody's having too much trouble with that one. In B, they say, according to the graph, are we endo or exothermic? So if the energy is getting colder in the system here, we're talking about an endothermic reaction, okay? And what the explanation is temp of the system is decreasing. Now, C is where the rubber meets the road. Now it starts to get a little bit hard. Its strengths of the interaction between the solute and between the solvent, are they greater than, are they less than that of equal to the strengths? And so what we're going to say is, because this is endothermic and we're going to have to put energy into it, then what we're saying is the solute-solute interactions, as well as the solvent-solvent interactions, are really going to be much stronger than the solute-solvent interaction. See, it's going to be at a more comfortable level, at a stronger, higher level, due to the solute-solute interactions. So the NH4NO3 sticking together, the H2O sticking together because of those hydrogen bonds. Those hydrogen bonds and those ion-ion forces are stronger because that's what we have going on over here. The solute is an ion-ion force, and the solvent-solvent is an H-bond force. But really, what force is going on in that solute-solvent is an ion H-bond. An ion, and not even an H-bond, excuse me. Even lesser than that, an ion dipole force. Not going to be strong enough. So the forces before are stronger than the forces after. That's what makes it endothermic for us here. Okay? And I think that's all we had, A, B, C. And then we skip. Their answer key isn't terribly good here. And then we get to question 2, a little bit of bonding, really pretty easy here. What they're saying is, hey, here's a particle diagram representation for F2. Please do the same. Well, okay. I don't know. Here, I'm just going to say, there's my shaded for my carbon, and then I've got four little red ones. Kind of got some gray in there. I don't know, didn't really work out all that well. Not working with the white. I can't really get the color I want, so I'm just going to make him a blue and shade them in with a line. I think that would be fine. I think we'd be okay with that. Same thing going on. They want the CH3F on the other side. We'll make the blue, draw the line, give the H's. I know they're supposed to be black. It's not even that much, is that you have 3 solid spheres and 1 empty sphere and a gray sphere. And, you know, are we going to worry about scale drawing? No, not so much. Then this one's going to be a solid sphere and an open sphere. Wow. Couldn't ask for anything better. I struggled with it. It's a drawing. Of course, I'm going to struggle with it. Okay. But particle level representations we've seen come up over and over again, both pictorially drawing as well as describing particle level. So that's going to be a real deal. Let's make sure we address that when we take the test. B, use the bond energy tables below to calculate what's going on. So we got to break everything apart. We're going to break apart 4 times 413. Okay, this is going to be bonds broken, break apart all of your reactants, and bonds formed. So we're going to break apart 4 carbon hydrogens. Then we're going to break apart 1 F2. Bonds broken. Minus bonds formed. Well, in this case, I'm going to form 3 413s and 1 plus, come on, Steve. Plus, I'm going to make 1 C to F, which is going to be 485. Plus, I'm going to make 1 H to F, which is going to be 567. And if we munch and crunch them, you're going to get negative 484 kilojoules. If you wanted to, you could make these hydrogen bonds that are coming on here. I've got 4 hydrogen bonds. I've got 3 hydrogen bonds. So if we wanted to, we could very easily, we could cancel out those 3 and make that 4 into a 1. We could do that. They wouldn't fault your credit. I just have always break everything, put everything back together. Yes, I know it's a wash, but in the days with these calculators, won't take you guys more than 2 seconds to do that. Okay, then let's look at C, another energy level diagram. How many of these have we seen in the last couple of weeks? A lot. And now what they want you to do is they want you to go back, and use that number that we just calculated. They want that number. It's exothermic. So what do we do with that? Okay, well then we're going to have to give off a little bit of energy down here. And we want to put our products on there. So our products end up being HF plus CH3F. And then it says, draw a vertical double-headed arrow on the graph to represent delta H. And that arrow could be anywhere between the reactants and the products, but that's what we're looking for. So we've got a nice little bonding problem. We have some bonding energy. We had reaction coordinate. We had particle level diagrams. We had a lot of the same things, Lewis structures, solute solvent interaction, IMFs. Those are still IMFs. A lot of the same stuff we've seen over and over again. That's the answers to FRQ unit. Progress check unit 6 FRQ. I am Smath and I hope this video helped you.